Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today our topic is scalar and vector. What is scalar and vectors? These are the physical quantities. Physical quantities have already studied in chapter 1, unit 1. I will define first what is physical quantity. All those quantities that can be made as a physical quantity. It means that around about all the quantities comes in the category of physical quantity because we can measure it. Measurement is basically the comparison of the known quantity with the unknown quantity. Examples of the physical quantities are the speed, displacement, length, height, distance, velocity. All these are the physical quantities and many more. Now come to the main topic, that scalar quantity and vector quantity. Physical quantity are mainly divided into the scalar quantity and vector quantity are the basis of the behavior of the quantities. Such is some physical quantity that depends upon the direction and some physical quantity that doesn't depend upon the direction. Scalar quantity, if these are the physical quantity that can be completely described by only magnitude. It means that scalar quantity are those quantity which doesn't depend upon the direction. These are also known as non-directional quantities. Means and scalar quantities doesn't depend upon the direction. It depends upon only on magnitude. So if you have to describe scalar quantity, you only have to magnitude. You only specify its magnitude. It will describe the scalar quantity completely. And what is magnitude? Magnitude is the number with proper unit. Scalar quantity or non-directional quantities, okay, and these scalar quantity can be added, multiplied, separated as ordinary algebra. Means they are simply just as we do in mathematics. We can add scalar quantities, multiplied and separated, same is the case. And example of the scalar quantity is mass of an object. We represent it with m, small m, and mass of the object, and it is 5 kg. If somebody tells you that 5 kg of sugar, 5 kg of mass, it describes completely that thing. It doesn't need direction. If somebody says I cover 2 meter distance, d we can also represent it with L or D. So 2 meter is the magnitude. 2 meter, 2 is the number, and meter, m is the proper unit. Okay. These are the two examples. I have already told about it, that 5 kg mass is a scalar quantity, and also distance is a scalar quantity. It doesn't need direction. Okay, come to the next, vector quantity. Vector quantity are those quantities that depend upon the direction of the body, direction of the object. It also depends upon the magnitude and as well as direction. Okay, these are also known as directional quantity. It means that these quantity are always depend upon the direction. You have to specify direction and magnitude both. so that you could completely describe vector quantity. Example of vector quantity are velocity, displacement, acceleration, momentum, torque, etc. These are all the example of the vector quantity. These because these depend upon the magnitude as well direction. The next topic is representation of vector. How we could represent the vector quantity. First is symbolic representation. We could represent a vector with a simple symbol with the capital letters A, B, C or D, anyone, and headed over an arrow. It shows the direction. It also means that the specific quantity is a vector quantity. If I know that a vector quantity is 5, a unit vector, then it is known as this is the vector quantity. So come to the graphical representation. In graphical representation, it is represented by an arrow, such as that one. We can represent it by an arrow. This is the tail of the arrow, it is the head of the arrow. The head of the arrow shows the direction in which direction it is, and the length of the arrow show the magnitude of the physical quantity. So the length of the arrow show the magnitude, and the head show the direction of the vector. These were some discussion about the vector, and also we can we use different algebra, specific algebra for the vector quantities to add, to separate, to multiply, to divide it. So in the next lecture we would discuss about the how we could add, how we could separate, how we could multiply these vector quantity to vector quantity in the next lecture. Okay, thank you. Hope you will understand my lecture. And your assignment is you have to you have to write down some example of the vector and scalar quantity, and you will also give one sentence statement why it is vector quantity and why it is scalar quantity with each example. Okay, thank you.